This is a very famous random distribution function, and maybe you recognize it. We'll talk more about it. Here's the equation that generates the probabilities. We're going to use this formula to produce values 0, 1, and 2 that are going to give 3 probabilities that should add up to 1 and should be between 0 and 1. So let's see what happens. This is a combination. So when I see 2, we're going to start with 0. 2 choose 0 is going to be 2 factorial over 0 factorial over 2 minus 2, or 2 factorial. What is that? 1. So this will be 1. 2/3 to the 0 is 1. 1/3 to the 2 is 1/9. Oh, that was easy. 1/9. Okay, let's go put the 2 in this time. I'm going to skip the 1. Put a 2 in this time. So 2 choose 2 is 2 factorial over 2 factorial over 2 minus 2, or 0. Oh, wait, what's that going to be? Still what? Still 1. 2/3 to the second is 4/9. 1/3 to the 0 is still 1. So this one is just going to be 4/9. Now, what do you think it's going to be for 1? What do you think the probability will be for 1 unit, x equal to 1? What do you think, Jesse? No idea? Okay. Can you help, Catherine? 1/9, 4/9. Any idea what that one's going to be? Miles, what do you think? Why do you say 4/9? Got to add up to 1. If these are the only possibilities, 0, 1, and 2, then all those possibilities have to add up to 1. And you're exactly right, but let's see if it does add up to 1. Maybe I did something wrong. So put in a 1 here, and so you get 2 choose 1 is 2 factorial over 1 factorial. 2 minus 1 is 1 factorial. This is just going to be 2 2/3 to the first, 1/3 to the first. What's 2 times 2/3 times 1/3? Fraction time, right, Zach? 4/9? Yeah, there you go. So these all add up. So one form that we could do is this equation. One form is the table. Another form is we could just plot this out. Here's your 0. 0 is going to go up to 1/9. This will be 4/9. So this is 0. This is 1. And this is 2. And so you can really see visually quickly that these probabilities for result 0, 1, and 2 look like. Then they could ask in IB, they might ask some questions. What are you thinking the probability will be if x equals 2? Well, that one you should be able to answer. Everybody. 4/9, yeah. And this one, x less than or equal to 1, that would be a 1 or a 0, so you can see how that's 5/9. So this is the one that I kind of did for you that kind of show you how these work out. Table, graph, and function form. Now let's talk pinball. I don't know if you knew this, but one of my hobbies are pinball. I have 2 pinball machines at my house. I discovered 2 years ago that there's a company that produces an app that will make computerized pinball machines from real pinball games that exist, and I own 65 of those, and they're great because they never break down on my iPad. But anyway, I hooked up a screen up on a wall, and then I made a fake box that looks like a pinball machine, and then it mounts my iPad on there, and I play pinball just like pinball on it. It's really great. And I think you can buy them for like, $3 a piece. Real pinball machines, pretty fun. But anyway, here's 2 pinball players, Joe and Kit. Joe is really good at pinball. He wins 70% of the time. Kit, I had a friend in college named Kit. She married my roommate. And she's a little better, 0.85. Now here's what we want to do. You are going to generate what's the probability if they play that no one wins, that one person wins, or they both win. And we're going to fill out this chart, and then eventually we'll answer this bonus question. Good luck. So if you are going to talk about the probability of nobody winning, 2 slots here. Joe is going to lose. What are the chances that Joe loses? 0.3, right? What's the chances that Kit loses? 0.15. Yep. And that's going to be, what is that, 0.045? Is that right? 0.045. I like the table a lot. So I'm going to go down to this number 2 here. What if they both win? Well, that's 2 slots again. And you have probability of Joe winning is 0.7, and then of Kit winning is 0.85. Now this one's kind of nice. This one's point what? Give me 3 decimals. 0.5. A little louder. 95. All right, so if we were to add these up, 0.0045, 0.595, that adds up to 0.64. What would you guess that one win would be? 0.36. That's what I'm guessing. That's what I'm hoping. Let's see if it actually comes to play. So here's what's happening here. In the first case, Joe wins. But in order for one of them to win, what does Kit have to do? Joe wins, but Kit loses. And if Joe loses, Kit has to, if there's one winner, she has to win. Okay? So when I multiply these, do you get 0.36? I hope. There you go. You got it. How many had that for those 3? That's setting up a random distribution. On the IB test, I see this a lot. Give you functions and just analyze them. Little fun extra probability that knowing one person won, it was Kit. So you have a little conditional here. The probability knowing that one person won, that it was Kit. Well, what is the probability that Kit won and it was only her? What's that probability? Kit won, 0.85, and what would Joe have to do? Lose, yeah. So that was 0.3. And then over one person winning, well, that's your 0.36, right? So you can figure that out pretty easily. Good. All right, so the last thing I want to look at is mean and variance. We're not going to talk about variance yet, but it's coming. But the mean is essentially the expected value. So whenever you see mean, I want you to think expected value. And the way you find the expected value is you're going to take each probability. So here's the probability, and you're going to multiply by a value associated with it. That makes totally no sense, right? Wrong. We're going to do a game that's going to completely bring this together. Most of you have done games where you've either hopefully not put money down, but you've played games and you're wondering, is it a game that I'm likely to win or likely to lose? You have the mathematical power as of right now to figure out whether a game is a game you'd want to play or not. If a game is one you can win, you should be in the plus category. If it's a game you're going to lose, it'll be in the minus category. And so let's take a look at one. This is called Chuck-a-Luck, and Chuck-a-Luck is a great game that is so easy to play. We're going to have Jake come on up here first. Give Jake a hand. He's going to play against the odds. And so if you're trying to find the probability that you get a number that you choose 3 times. So let's make a little chart. You have, you get your number comes up 3 times. Okay, that means, what's the probability of getting your number the first time? 1 out of 6, right? So there's a 1 out of 6 chance. Then, what's the chances of this one getting your number? 1 out of 6. And what's the chance of this one getting your number? 1 out of 6. So it's this, then this, then this. What do we do in between? Multiply. And so that's going to give me 1 out of 216. So if I want to get 3, the probability is 1 out of 216. Not very likely. I haven't seen it more than maybe 1 time in the last 8 years. Now, for 2 times, well, let's go 0 times, because that one's a little easier. So if you're not going to get the number you pick, how many values are there that aren't the one you pick? 5 out of 6. And then it'll be, for the second one, 5 out of 6. Third one, 5 out of 6. And so this is going to be equal to 125 out of 216. This is the most likely thing to happen. 125 out of 216. The ones that get tricky are the ones with 1 or 2. But let's do 1 time. You get the number you want. Well, let's say the first one you get 1 out of 6. But what would the other ones have to be? 5 out of 6 and 5 out of 6. And how many different ways could you have one answer correct? How many ways could this happen? The first one could be the right one, the second, the third. So how many ways? 3. So you're going to multiply by 3. So this is 5 times 5 is 25 times 3, which is 75 over 216. Did I lose you? Are we okay with that? Okay. And then the last one, 2 of them show up. With this one, you have a 1 out of 6, a 1 out of 6, but the third one is going to be a 5 out of 6. And how many ways can this happen? The first one isn't the one you want, the second one isn't the one you want, the third one isn't the one you want. So we're going to multiply by 3 again. This is the part that people probably forget. So I get 15 out of 216. Oh, wait a minute. 15 out of 216? Is that right? What's 75 plus 125? 200. 201 plus 15 gives me what? There you go. So we know we did it right. Ta-da! Those probabilities look great. Those look great. Now's the easy part. Now we're going to find out whether this is a fair game or not. And so what expected value is that you will get $1 if you get 1, $2, $3, and -$1 if you miss all of them. And so we can take these values. The expected value is the product of these. So 1 times 75 2/16 plus 15 times 2 is 30 over 2/16 plus, boy, this isn't very helpful, 3 out of 2/16 minus 125 out of 2/16. So this is 108 minus 125. What's 108 minus 125? Negative 17 2/16. This is my expected value. We call the mean of that, sort of a mean expected value. And what is that? That's a decimal, negative 0.08. This means that every time you play, you should expect to lose 8 cents every time you play. So if you played 10 times, you'd expect to lose 80 cents. So it would take quite a few times, probably, about 13 games before you'd lose $1 on average. Isn't that interesting? That is expected value. And all you do is set up the probabilities and what your assigned values are, multiply them out, and you got it. Now, how does this apply to life? How many of you are 18? Have you bought a scratch off yet? Take one of those cards, and you go to the back of the gas station. They have a little chart of all the probabilities and how many cards there are. So what you do is you take those probabilities, multiply by how many cards there are, and then multiply by the value and add those up. And when you do that, it's set up so that every card you buy is a loss of between 30 and 60 cents. The expected value is going to come up 0.4 to 0.6 on every dollar. So if Miles gave me $1, I'd give him 40 to 60 cents back. That's what the lottery is essentially doing. Is it made for you to win? No. Is it made for you to lose? Yes. It's a fun way to lose money. I agree. Okay, so by the way, 52 years old, never bought a lottery ticket. Not yet. So the assignment for tomorrow is you're going to set up your own probability tables and answer some questions.